Good afternoon, everyone. Thank you very much for coming to our session, Your Hacked End-to-End Security in Practice. So who are we? My name is Karthik Shyamsundar. I'm a principal technologist at VeriSign. I also serve as an adjunct faculty at Johns Hopkins University, teaching courses on distributed computing and enterprise computing. There's my Twitter handle, and you can also email me at karthik.shyamsundar@gmail.com. I have with me Funny Patapu. Funny?
Hi, I'm Funny Patapu. I'm the software engineer at VeriSign, and my Twitter handle is @funnypatapu, and you can email me at funny@patapu.com.
All right, thanks, Funny. So what is the overall goal of this presentation? We actually have two goals. First, to give you an overview of the JavaE security features that can help you in building secure enterprise applications in the cloud. Second, best practices that you can employ while you're using these JavaE security features that's available in the platform. So here's the outline. First, we want to talk about the internet threat model. Then we're going to talk about the JavaE security model itself. Then we'll talk about securing the web tier. We'll talk about securing the EJB tier, the business logic tier. Then we're going to talk about securing the enterprise integration tier, your data services. And then some Java security challenges in terms of the EE platform, summary, and hopefully, if time permits, we'll do Q&A. It's going to be a packed, tight session, lots of stuff going on over here in this, and the slides will be available right after the session. Okay, so let's talk about the internet threat model. Well, thousands of mission-critical applications are being developed and deployed on the internet worldwide, but the reality is most of these applications are vulnerable to attacks by hackers and crackers. And an attack by a cracker or a hacker is detrimental for that particular company. I don't want to name any company or put any specific headline, but if you look at any of the security news or any of the internet news, cloud computing news, you see a lot of attacks like this. The problem is real, guys. The reality is cyber crimes and incidents are actually on the rise. And the interesting fact is that 3 out of 4 businesses are vulnerable to attack, according to Gartner. And the even more interesting fact is that 75% of the attacks actually take place at the application level. Now, when you're working for an enterprise, you're dealing with those security professionals that have all these firewalls in your company that make our life difficult. But the reality is that they're actually doing a fairly good job in keeping the hackers away in terms of network security and things like that. But when it comes to application level security, it's our problem. We need to take care of that. So here are the 7 steps of doom for many companies. They develop software, they deploy it, they get hacked, they fix the bugs, they deploy it again, they get hacked again, they fix the bug, and they just keep on going. It's a vicious cycle. What you really want to do is think about security when you're building software. Think about security, secure design, secure development, secure testing, secure deployment and operations, audit process, and most importantly, build your software on a platform that gives you the security features. And if you really think about it, the JavaE platform actually does that. So let's look at the JavaE security model. So the line over there indicates the client versus the enterprise. In your enterprise, you have your application server. You may have many of these application servers behind a firewall, behind a load balancer. You have the web container, the EJB container, and then you have your enterprise services, enterprise integration services, like your database, message queue, your EIS services, which is your mainframe systems that you may have to interface with, or other systems that you may have to interface with within your company, or even services that you may have to interface with in the cloud. So you have your web tier, your EJB tier, and the enterprise integration tier. In terms of client, you have standalone client or the browser. So when it comes to standalone clients, they can be non-Java clients, they could be Java clients, or they could be the browser. You could also have a Java EE client. There is something called the application client container, ACC, which is part of the Java EE specification that allows a Java EE client to talk to the application server directly to the EJB container. So you have standalone clients like browsers talk to your web container. The web container would end up talking to your business logic container, or it may end up talking to the EIS tier directly. And then the EJB container, the business logic container, will end up talking to your EIS services. Or your clients will end up talking to your EJB container directly, which of course end up talking to the EIS services. So what we are going to talk about in this presentation is how to secure the web tier, how to secure the EJB tier, the business logic tier, and how to secure your enterprise services tier, all based on the Java EE standards. There are certain things that we need to understand when it comes to application security. Authentication. Authentication is ensuring that the users are who they say they are. This is typically done by using user IDs or certificates, client certs. Authorization. Authorization is ensuring that the users have permissions to do whatever they want to do, the operations, which is typically done through groups and roles. Confidentiality or data privacy, ensuring that only authorized users can view the sensitive data, usually done through SSL or encryption. Non-repudiation, ensuring that transactions can be proved, that they happened, that the fact is the client did send the transaction to the server, and the fact that the server did send the transaction back to the client. Non-repudiation on both ends, typically done using SSL. Auditing, maintaining a record of transactions for every transaction that you're going through, all the security auditing information. Quality of service, this is important too, ensuring that the users experience a good quality of service when they are using your application. The most important thing is that the Java EE App Server and the app services offer several mechanisms that actually address all these characteristics of an application security. There are two ways to express security in your enterprise application. There is the declarative way or the programmatic way. In declarative way, there are two choices. You have Java annotations, where when you write a class or when you write a method, you can put annotations in your class. The advantage is you can do security annotations right there as you're writing your code. The disadvantage is that you're keeping your security characteristics, which are architectural characteristics, as part of your code. But there's one more slight disadvantage. It's not a big disadvantage, which is there's limited functionality when it comes to annotations. You can do a lot of things with declarative XML deployment descriptors, but there's a few things that you cannot do with annotations. The deployment descriptor annotation, of course, the advantage is that it keeps security concern outside your code. And the most important thing is that it can override security features defined through the annotation. So at deployment time, you can do different things. When it comes to programmatic annotation, many times declarative security is not good enough to solve your problems, in which case you end up going to programmatic annotation. And the logic is embedded in your business logic. The most important thing is you should prefer using declarative security and drop down to programmatic security only if the declarative security is not going to solve your problem. In fact, Funny is going to talk about that. So in Java EE security, there is a bunch of terms that we need to understand. User, credential, group, identity storage, security realm, principal, role. So let's talk about those things. User, credential, and group. According to Java EE specification, a user is an individual or machine. Don't forget, users can access your system, or other systems, machines can access your system. But the most important thing is whose identity is defined in the identity storage. So there is something called an identity storage where you have to keep track of the users. That's how they define a user. Credential. Information used to authenticate a user. Typically, it's a password, but it could also be a certificate for two-way authentication. Again, this information is stored in some kind of a storage, identity storage. I know I haven't talked about identity storage yet. It's coming soon, but we'll get into that. Then you have group. It's a set of users with a common set of characteristics that have a common set of permissions and access levels to access certain resources. You take a bunch of users, put them into a group. In this case, I've taken user 1, user 2, and user 3, put them into a group called manager, and this information is again stored into an identity storage. So what is this identity storage and the related term security realm? An identity storage is where you place your user, group, and credential information in some kind of a storage. It could be a flat file. It could be an RDBMS system. It could be an LDAP server. It could be a certificate repository. And a security realm is a term in Java EE where it's a mechanism by which an application server stores and, most importantly, retrieves users' credential information so that it can do the authentication and authorization for that particular user. Glassfish application server, which is what we like to use, I'm going to talk about that in specific over here, provides 4 major realms. It offers file, JDBC, LDAP, and cert. In fact, it also offers PAM for Unix, and it also offers custom. So if you want to do your own authentication, identity storage, you can do that. So let's take a look at the JDBC realm. So typically when you have users in the JDBC realm, that's the most common way, because in a JDBC realm, that's where you want to keep track of all the users rather than a file. So you would have something like a user table. The most important attribute over here is the username attribute, and of course the credential, which is the password. And then you have a group table, which is the list of all the groups that you may have in your system. The most important attribute in that particular table is the group name. And then because a user can belong to multiple groups, and the fact that a group can have many users, what you want to do is it's a many-to-many relationship, so you may want to have some kind of a join table that joins everything together. And then what you really want to do is put some kind of a view on top of that. And this is how you do it in Glassfish. So you put a view on top of that where you have the username and the password and the group name, and then you can insert records into the groups and users. So what I'm showing you over here is how in Glassfish Administrative Console you can say what the JDBC realm is, that's what, which is the class that represents the realm. And then you can also give a name for the realm, which is the JAS context. You can also give the JNDI name of the data source, which accesses the database so that the application server can do the authentication. There's also a user table. Of course, in this case, it's going to be the virtual table. And then you have the username, the password, and the group information all available. You configure this. Now, you can configure all these things using a console, or you can use something like an AS admin tool to configure all this. Every application server does it differently. Now, let's talk about principals and roles. So you have the concept of principal. A principal is really a Java EE concept for a user. There's a class called java.security.principal that represents a user, because a user in Java EE could be a regular user with username, or it could be a client-side certificate. So there's actually an X509 certificate that inherits from the principal class. When it comes to role, it's the groups that maps to the Java EE roles. And once again, you have the group information, which gets mapped to the role. The mapping of the principals and the roles is done in the application server using a vendor-specific file. For example, in Glassfish, there's a file called glassfish-web.xml file, which is in parallel to web.xml file, where there's an element called security role mapping, which maps the Glassfish roles. In Glassfish, you don't talk about in terms of groups. You talk about, in Java, you talk about in terms of roles. So you take a role, and you can map the role to a group or multiple groups, and then you can also map it to principals. You can have as many of these roles defined. Okay, so now you've taken the physical world into the Java EE virtual world. So let's talk about the web tier security now. All right, so if you think about it, your clients, which are the non-Java clients, in this case, the standalone clients, the browsers, they're trying to access a resource in the web container. And if the user's resource in the web container is a protected resource, then credentials need to be exchanged between the client and the server. And so the application server kicks in and tries to get the credential exchange done. Okay, so what is authentication? Well, authentication in the web tier, we know that authentication is really proving who you say you are. In the web tier, there are 4 authentication mechanisms. There is the basic, the digest, form-based, and client cert. And I'm going to go through each one of them. It's really important to understand the differences between these things so you can make the right choice for your application. So we'll talk about the pros and cons of each one of these things. When it comes to doing authentication in the web tier, you can do it declaratively using XML-based annotation. You can also do it programmatically, which is a recent API as part of the Servlet 3.0 specification. If you want, you can, remember we said in declarative annotation, there's the Java-based versus the XML. There's really no annotation for this. It's only XML-based. So let's talk about declarative authentication in web.xml file. You have your web.xml file. There is an entry called login config. This is all part of the Java EE spec, where there is an attribute, there's an element called auth method, which has one of the 4 different values: basic, digest, client cert, and form. Again, I'm going to talk about these things. You have to pick any one of these things. And then there's something called the realm name. So this maps the application server's realm that we defined. We actually defined a JDBC Realm. There's a name that's given in the configuration level. And then there is also something called the form login config element, which is used only for form-based logins. When we talk about form-based logins, we'll talk about that. Right. So let's talk about declarative authentication using the basic method. In this case, you define login config. You say auth method is basic. And by the way, I left an element here, which is the realm name. You can add that in. It's part of this, and I just wanted to keep it simple over here. The basic idea here is that you have a user. The user wants to access a protected resource. So when the user accesses a protected resource, the application server says, wait a minute, this resource requires some kind of a role. You need to authenticate. So the application server simply sends an HTTP 401. Remember, this is basic authentication. In basic authentication, when the browser receives a 401 with the realm name, which is the special www authenticate header, the browser says, oh, I need to pop up a dialog window. It pops up a dialog window, asks for the username and password. You enter the username and password, and that information is sent to the server using this specific header called the authorization header. The most important thing to remember here is the password is base64 encoded. It's not encrypted. And of course, once you're authenticated, you basically are able to access the resource. And there is no concept of logout over here, right? Because the browser is maintaining the session all the way through. In digest-based authentication, it's pretty much the same story. The user accesses this protected resource. The server sends back a 401. A pop-up happens. And then, in this case, it sends back, a little bit more things happen. There's another negotiation, nonce and all those things. But the reality is, in this case, rather than sending the password in base64 encoding, it actually sends the digest. So the difference between the basic and the digest is the fact that you're not really sending the password here. You're only sending a digest, some kind of a hash from the client back to the server. What this also means is that one of the things that we noticed was in your application server, when you're storing the password, you need to make sure that you actually create the digest of the password when you store the password and not really the password the way it is. Okay, so now let's talk about declarative authentication using form. This authentication is a really nice authentication because it allows you to build your custom forms, because the other one is pretty ugly. You have this pop-up window that comes up from the browser. So the idea here is that you create a page called the login.html or the login.jsp, which has a form in it. It has 3 major elements. There is J_security check, J_username, and J_password. These are 3 things that are defined as part of the Java EE specification. So the idea here is that the J_security check is a very special service, a very special servlet that gets called upon, which does the authentication for you by the container. There is also an error page that's available. So if the authentication ever fails, it'll actually end up going to the error page. So in this model, when you say login config auth method form, you basically define the login page and the error page. And by the way, it can be the same page if you want. You can do some AJAX over there. And the idea here is that the user accesses a secure resource. When the user accesses a secure resource, the application server says this requires login. So the application server, rather than sending a header, which is the www authenticate header, it ends up sending an HTTP 302 back to the client, redirecting them to the login page, which is the custom login page that you wrote. So the browser gets the login page. The login page comes back. The browser displays it. The user types in the username and password. Remember, J_username and J_password are the 2 special form elements that get submitted to J_security check in the form of post. The application server then uses the mechanism to log in. It logs in into the data from the realm, which is the JDBC realm in this case, sends back a redirection saying that everything is good and redirects you to the original page that you're asking for. And all these things are happening within a few milliseconds, hopefully, if the network is good. So here the username and password is sent via post. It's not encrypted, so you have to make sure that you use the appropriate transport. Again, Fanny is going to talk more about this. The next authentication model is the cert-based authentication model. Here, the auth method is client cert. The key here is that you expect the client to have some kind of a client certificate. Of course, I work for VeriSign, and we had the security business, and we would want everybody to buy a certificate, client-side certificate. This is definitely a very nice authentication model. In this model, the client has a certificate. So it's a little bit more complicated when it comes to negotiation. Here, what happens is the client makes a request to a resource. The server basically does mutual authentication. Remember, this is client-side. It's not just the server-side certificate. When you have a server-side certificate, all you're saying is that the client says, yeah, I know you're a good server. But when you have client-side certificate, the server says, I know you're a good client. I know you're you're a client that has been validated. So there's a bunch of authentication. There's a bunch of conversations that go back and forth, and I can talk to you about that for an entire hour. But that's not what this is all about. But anyway, the negotiations take place, and eventually, the authentication takes place, and you get sent to the right page. It's a stronger authentication model when you want to do things like financial transactions. Maybe this is a model you can use, and it uses digital signature rather than regular password. All right. So now all this is great, but how do you do programmatic authentication in web tier? For a long time, we didn't really have that. What I mean by that is, in Java application server, when you access a resource, that's when the authentication kicks in. Right? If you're accessing a resource that's not protected, authentication is not going to kick in. There was no way to actually force authentication. But when you're building applications that are AJAX-like applications, where you have a form and you want to specifically go ask for authentication and still want to use all the other mechanisms that's available as part of the Java EE for protecting your maybe RESTful services and things like that, because now the programming model is shifting more towards RESTful API, HTML clients, JavaScript clients, making RESTful calls, and you're exposing everything as a RESTful API. You still want to have all the Java EE security model built into it. We have programmatic authentication that allows you to do that. So now, as part of the HTTP Servlet specification 3.0 specification, you have a method called login that's available, which takes the username and password, and you can log in. So you fill a form, you submit the form, and then you can do the login explicitly using this particular API. And then there is also a method called authenticate now that's available that allows you to instigate login if you are in a page that is an unconstrained resource page. Of course, once the user is logged in, you have a session, and you want to make sure that the session is managed. Because as part of security, you want to make sure that the session is managed, that when somebody's logging in from a public library, the session is not open for the next 10 years. So you want to define idle session timeout. In your web.xml file, declaratively, you can do this by having a session config set to 30 minutes or 15 minutes or whatever you want. The application server will set your timeout. You can also do it programmatically by invoking the session.setMaxInterval method. So that's how you define timeout. And now you also have an explicit way to invalidate a logged in session by invoking a method called logout. So now logout is also a complementary method available as part of the Servlet 3.0 specification. So you can do a logout. Fanny is going to now talk about authorization.
Karthik already mentioned a little bit about authorization, and it's a very basic concept that everyone is familiar. So it just basically refers to access control. It's a way to regulate access to functionality based on the role that the current user is using. So it can also be achieved, just like authentication, authorization also can be achieved either declaratively or programmatically, or a combination of both declarative and programmatic. Let's look at declarative authorization in web.xml. So first, the foundation for any authorization is being able to define the roles. The declaration or definition of the roles happens in web.xml using the security role and the role name tags. So you specify a list, basically an enumeration of all the roles supported by your application in your web.xml. You can have as many as you want. So once the roles are defined, then you need to start specifying your security constraints as to who can access what. So now you need to, inside the security constraint, you need to specify what is the web resource collection that you're trying to protect. So you can give the name to the web resource collection, and then you have to specify the URL pattern that is in the context of this web resource collection. Then once you have the URL pattern, so by default, if you don't specify any HTTP methods, then all the methods are applied within this web constraint, web resource collection. But then, if you specify one or more of the HTTP methods, then only these methods will be protected by this authorization constraint. So you can specify one or more of these. We get, post, put, options, trace, anything that you want. Or you could specify HTTP method omission. What happens here is, so only these methods will not be protected and everything else will be protected. So if you don't have HTTP method or method omission, either of those, then by default, everything will be part of this web resource collection. If you have specific HTTP methods, then only those will be part of the web resource collection. And if you have only HTTP method omissions, then everything except those will be protected. Now, once you specify what the web resource collection is, now you have to specify which roles have access to this web resource collection. So you can do that using auth constraint and role name tags. So there's also another element called transport guarantee, which you can look at in transport layer security or confidentiality section. But this is basically how you define a security constraint. So let's look at an example. So you start by defining your roles. Very simple example, we just have one role here. And we start with your web resource collection. So in this, I'm calling the web resource collection as payroll. So the URL pattern is specifying is payroll /asterisk. Now, I'm saying I want to protect the get method, and I also want to protect the post method. And the authorization constraint says HR is only allowed to access this get and post. So basically what I'm saying here is that the get and post methods must be accessed by users who have the role HR. So we're not talking anything about other methods like put, delete, post, options, trace. So they are not part of this constraint. So we can have another constraint to protect those, or you could leave them open if you wanted to. And then there is the transport guarantee, which we'll talk later. Let's look at declarative authorization using annotations. So there's a few annotations that are introduced, one of them being declarables. It's an interesting annotation where this is typically used in conjunction with programmatic security. It's very similar to the security role that we just saw in web.xml. It's basically used to declare a security role for a specific class, at a specific class level. So you have the servlet security. So this is very similar to, it has the same connotation as the security constraint tag that we saw in web.xml. But it can be applied to a servlet to define different specific constraints. And you have a HTTP constraint. So this is basically, there's no tag for this, but it's basically if you don't have any HTTP method or method omission, then by default, everything is protected. That's basically what it does in terms of annotations. So you can also write specific constraints which are specific to a particular method, HTTP method, that you can use HTTP method constraint to that. And there is also an annotation called run as, which is used in security propagation, subject propagation between the web tier and the EJB tier. All right, let's look at an example. So you have a simple servlet, and the URL pattern for the servlet is /payroll. And we start with the servlet security. So one of the things you can do in HTTP constraint is you can also specify the transport guarantee as well. We'll talk about it later. But what I'm saying here, the interesting thing here is we're saying the roles allowed is manager. But we're not saying what method we are talking about. So what happens is that any HTTP method in this servlet can be accessed by manager. That's a constraint. So you can also add specific method constraints which take precedence over the HTTP constraint. So first constraint we're putting is the get method can only be accessed by HR role. And we also say we're saying the trace method, but we're not saying what role is allowed. What that means is that anybody can access the trace method. We can also do something like this, where I specify the method as delete, but I basically write a flag saying empty role semantic is denied. So I'm basically reversing the meaning of the empty role, saying do not allow anyone to access the delete method. So in summary, what's happening here is that no one can access the delete method. The trace method can be accessed by anyone. The get method can only be accessed by HR. And anything else, like for example, put or post, can be accessed by manager role. Okay. So how do we do programmatic authorization in the web tier? So Karthik covered a few APIs in the HTTP server request. So there's a few more. One of them is get remote user. It basically returns the username of the currently logged in user, authenticated user. And you have the get user principal. It basically returns the principal object representing the user or the file that's currently logged in. It's in the security package. And you also have a method called isUserInRole, which basically tests if the user, current user, has a role that is specified in argument, and returns true or false based on the assertion. Let's look at an example. So you have, again, a simple servlet. So we have to declare roles. So earlier I mentioned that declare roles annotation is used in conjunction with programmatic authorization. So basically, for you to use a role inside your application API with the code, you have to declare it in as declare roles. Or it could also be present in the web.xml. You could do one of these two things. So in this example, we're declaring the role HR using declare roles. And a simple assertion I'm doing is request.isUserInRole HR. If it is, then do something. All right, let's talk about confidentiality and non-repudiation. Karthik kind of briefly went over confidentiality and non-repudiation. So basically, it's a way of protecting the data that is communicated between the client and the server, and also making sure, in terms of non-repudiation, we can basically confirm that whoever is claiming that they can basically be asserted. So you can use HTTPS to secure the communication. So it basically uses the secured sockets as a transport layer, and it basically encrypts all the data communication between endpoints. So you can achieve non-repudiation. Again, server, everyone identifies the server, but then how do you identify if the client is who it says it is? So for that, you can use the client certificates. So we kind of looked at the transport guarantee element in web.xml that we said we're going to talk about later. That's the element we can use to ensure confidentiality and non-repudiation in our application. So it basically takes on three values, which is confidential or integral or none. So confidential basically says that the data is protected, and the integral value basically says that the data is not tampered in the way. But then there's typically one way of achieving it, which is basically using SSL. So in Java EE, typically they have the same meaning. It doesn't really distinguish much between what they really do. They do the same function. So again, you can just use this tag in the web.xml like we saw earlier. And if for some reason in your application, if you had to verify how the request is coming in, what scheme it's being used, HTTP or HTTPS, you can do that using a get scheme method on the request object. Okay. Auditing. Again, we're all mostly familiar with filters. So filters are a great way of doing auditing inside the web tier on EJB inside the web tier. So you can basically configure filter, and you can basically write a simple filter which basically logs the request and response. But one thing we're not talking about is vendor-specific stuff. So basically, Glassfish has a rich logging mechanism for auditing. So you can basically see who is logging in, who is logging out, all those things are available readily in Glassfish. You can do a lot of configuration, tuning of that as well if you wanted to. And there is also a custom API class called Audit class that's provided by Glassfish, and similar stuff in other vendors as well, which you can use to write programmatic auditing, more sophisticated auditing, or more easier auditing, yes. So quality of service. Again, Karthik kind of went over this also briefly. So it's basically a way of making sure that high quality of service is provided to all the users. That keyword is all. So it's a way to ensure, we need to try to ensure that as a user, a particular user, or a set of users are not depriving the rest of the users of the resources that they need. Right? So one of the things that people typically do is denial of service attacks. Again, we're not going to go over everything that you can do to stop denial of service attack. But some things you could do here is, because what people are trying to do is they're trying to basically consume the scarce resources that are available, like network bandwidth, CPU, memory, things like that. So you could basically, in architecture, one thing you could possibly do, which could help, is trying to identify different classes of users and trying to segregate the resources for appropriately, so one group of users do not affect the others. So you can also prevent hackers from basically injecting malicious code, doing things like cross-site scripting, cross-site request forgery. And there was a really good session about this kind of stuff, more detail onto cross-site request forgery and stuff yesterday. Masood and Mike did this talk yesterday. I mean, probably should be online sometime later, so I'll recommend you to check it out. And so basically, just to go over the fine details, you should never touch a client, obviously. So you should assume that all clients are bad clients. And assuming that you validate all the input that your application receives from the client for different aspects like correctness, the type, format, whatnot. And typically in your application, if you have any access control mechanisms, try not to use blacklisting or use whitelisting, meaning completely seal it off and open it up to people who need it, instead of basically saying it's open and then I'll blacklist this guy and this guy and this guy. So it's a better approach to doing security. And try to escape all the input for HTML encodings and things like that, so you don't basically get execute malicious code on your application. And also, likewise, when you send out output, try to encode that as well. So one more thing typically you would want to do is, again, these are all going back to the basics, try to protect your internal details of your application from other people. So try to use server-side comments if you're doing that, use AJSP-style comments, have mapping pages for exceptions and errors. So there's a lot of information available on this. Karthik actually did a couple of talks a few years earlier at JavaOne on this series, You're Hacked. So first talk was in 2004. It was top 10 secrets for securing your JET web applications. And he did a talk in 2007 as well, which is more about AJAX security. So both the talks, including this one, will be available actually at yourhack.com for you to download if you're interested. All right, let's talk about EJB Tier security. So we probably see this diagram all for the third time here. But so what's happening here is, so when you talk about authentication in the EJB tier, so there's typically two ways of that happening. So the users log into the web tier, and then they try to access the functionality of the EJB tier via the web tier. So in this case, the container basically makes sure that the subject propagation is happening. The security context is being propagated from the web tier to the EJB tier. So the other way of doing that is, you might have an application client container where there's an EJB client, standalone client, that's trying to access the EJB tier directly. Even in that case, the application client container, the ACC, basically has mechanisms to do authentication. And once it basically passes the authentication, when it makes a call to the EJB tier, then it propagates a subject security propagation happens, like similar to the EJB web tier propagation. So the authentication on the application client container is very vendor specific. All the configuration is vendor specific. There's not much written in the spec about this. So I'm not going to cover that as part of it in this presentation because we're trying to do just Java EE for now. So if in case you wanted to do programmatic authentication, again, just as an example, Glassfish has a way to do programmatic authentication on the web tier, on the EJB tier as well. It's very vendor specific. So that's the class that they have, and they have a couple of methods for login. I mean, they actually have two for web tier and two for the EJB tier. So you can basically pass in the username and password, or optionally you can also pass in the realm and the errors boolean as well. It will basically establish a security context if the username and password match the ones that are in the realm. And you also obviously have the logout method, which will attempt to log the user out, basically pose the security context that's established. All right, let's look at authorization, declarative authorization using EJB jar XML. So just like you do it in a web tier, even the EJB tier, you need to specify what roles we're trying to work with. So you need to specify all the roles that are going to be used in the EJB tier. So once you do that, then similar to what we have in the web tier, web.xml, where you have security constraint, we have method permissions here. So in web tier, we were talking about how to authorize at the level of the granularity of a HTTP method. Similarly, in the EJB tier, here the granularity is an EJB method. So we're trying to define what are the permissions available for a specific method. So we start with a user-friendly description, and we start with a kind of a little bit different from web tier. So we start with a role name. You can have as many roles as you want. So you say what roles we're trying to permit. Or you can optionally say unchecked, meaning you're trying to open it up saying any authenticated user can access my method, which we are going to mention in just a bit. So you either specify a list of roles or say unchecked, saying, okay, anyone can access it. As long as they're authenticated, that's fine. So you can specify you should specify the name of the EJB that we're talking about and the method name. You could also do a wildcard here saying star, meaning it applies to all the methods in the EJB. And if there's any parameters, you can also specify the method params as well. So there's also a feature called exclude list, which basically says no one can access this. Again, I kind of didn't write the same thing again, but it's the same tag as above, the method tag. You write the EJB name and the method names and method params. But basically what you're saying is we don't specify the role here because we're saying no one should be able to access this. Typically, it's not very widely used. It's used in cases where you have the functionality written, but you don't want to use the functionality in this particular deployment. You said just don't let anyone use it. Okay? Let's look at an example. So in this case, what I'm saying is the role name manager. Anyone who is authenticated with the role manager can access the hire new employee method in the payroll service. I'm ignoring a few tags here like the description, name, and stuff, just to make it succinct. And the next one says the HR role. Anyone who has the role HR can access any method in the payroll service EJB. And here I'm saying no one can fire all employees. It just can't happen. All right. So there's a few more tags that we haven't looked at. We haven't gone into much detail. Run as. So sometimes you may want to control what the EJB tier. So when some functionality is being run as, you want to say this functionality should be run only as a particular role, regardless of the user that's currently authorized. So it could be a sub role, it could be a different permissions window. Again, this is not so widely used as well, but you can specify the run as in the security identity, or you can use the run as annotation as well on top of the EJB, or the servlet as well, actually. And there's also something called use caller identity, which basically says use whatever identity the caller has, just propagate it here. Okay? All right, let's look at declarative authorization using annotations. So we looked at a few annotations in the web tier, and in EJB tier, there's some overlap, but there's three major annotations. One of them is roles allowed. So it basically takes enumeration of roles, a list of roles basically, which can be applied to either a class or a method. And obviously when applied to a method, it basically says what are all the roles that are allowed to access this method. When applied to a class, it says what are all the roles that can access all the methods in that class. So there's also a permit all annotation. Again, as the name implies, it basically says that any role, any authenticated user with any role can access this specific method or all the methods in the class depending on where it's applied to. Likewise, there's the opposite of it, which is a deny all, so restricting access from everyone. And you can also use the declare roles annotation and the run as annotations that we saw in the vector, which they have the same meaning here as well. Let's look at an example. So we have employee service class. We're saying the roles allowed is restricted users. So basically, the view employee info method can be accessed by any authenticated user who has the role restricted users. And hire new employee, we're saying the roles allowed is manager. So any authenticated user, only authenticated users with the role manager can access the hire new method. Likewise, provide feedback, we're saying any authenticated user can access that. And same example, fire all employees, no one can access that. Let's look at programmatic authorization in the EJB tier. So EJB context has a couple of methods which basically help with the programmatic authorization. One of them is the get caller principle. So it basically is used to obtain the security principle that represents the identifier that identifies the currently logged in user. And you can also use the is caller in role. It's kind of similar to the is user in role back at the web tier. Basically, test if the current user has the role that we are looking for. Okay? An example. So let's say you have a payroll bean, and we say in the declare roles HR, so we're going to use the role HR in the is user in role. So we'll see that. So in the update employee method, info method, we're trying to get the principal name. We're trying to figure out who is currently logged in. And we're doing some database stuff to retrieve the user information by getting the name of the principal. And then we're trying to compare what's happening is we're trying to compare the current salary to the new salary that we're trying to set. And in order for us to set the salary, what we're saying is that the user that's currently logged in has to have the role payroll. If not, we're throwing a security exception. If yes, we will proceed with the for business functionality. So again, try to use declarative security as much as you can, but there might be instances where, I mean, this can be done perfectly with declarative as well, but there might be instances where you want to limit by, let's say, time. So payroll can issue paychecks between 9 a.m. to 6 p.m. Pacific time. That's it. They can't do it before or after. If there's some hypothetical constraint like that, then you can't obviously do that with declarative. That's when you would resort to programmatic. Auditing. Again, like filters in the web tier, you can use interceptors in the EJB tier, which provide a nice way of doing auditing. Again, I'm not going to go into too much detail of the auto interceptors itself, but there's nice annotations available to do those as well. So at interceptors is an annotation to use to apply an interceptor to EJB, and you can basically write your aspect functionality using the add-on invoke annotation. Okay, let's talk about EIS tier.
Okay, so we talked about securing the web tier. We talked about securing the EJB, the business logic tier. And now let's talk about securing the EIS tier. Right, so basically the idea here is that you have your application server which has the web container and the EJB container, but the reality is that your application server also has these integration services, database services, messaging services. It may want to access other services that's on the internet or within your company. So the idea is here in this particular section is how do we protect this, and what are the kind of things that you want to keep in mind there. So the first thing is stealing stored and transient data. Many security compromises are because applications store and transmit data in plain text, right? So really, the concept is you need to encrypt all critical data, passwords, cookies, hidden fields, whatever is important. Now, when I say encryption here, I'm saying it at a very high level. We understand the difference between, we need to understand the difference between encryption, which is two-way, versus hashing. So, for example, passwords, you want to hash. And the second thing I've seen in many places is people try to invent their own algorithm. Oh yeah, I'm going to take this and multiply it by 17 and add 45, and don't do that. Don't invent your own encryption algorithm. There are plenty of good algorithms that's out there. Believe it or not, I've seen it. We do WAMA review and we're like, oh, really? You think nobody can find that? Okay. So try to make sure that you use a library. And if you think about it, the Java JSCC library has a bunch of encryption algorithm built into it, and you may want to use that. Okay, so now let's talk about protecting the databases itself. Now, in your application server, you have data sources, and then you have your, your configuration, the database connection pool, and things like that. And of course, your database itself should have a username and password associated with it. Try to use the application server configuration to configure your application's data sources, because they actually typically encrypt the password. They keep the password in an encrypted fashion, rather than you keeping in some kind of a file in clear text. The other thing is, if you're using databases, this is true for pretty much any application, that is, whether it's a web tier that's accessing the database or the EJB tier accessing the database. If you're trying to talk to the database, prefer using JPA for CRUD operations, because what JPAs do is they try to generate prepared statements, or if you want to write your own SQL, prefer using prepared statements. Let me give you an example of why. For example, let's say that you want to take the username. It's a very simple example, an example of SQL injection, where you try to take the username and the password from the user, and then you want to build a SQL statement. So if you look at the SQL statement, it says select star from users, where username equals single quote, and then USR, which is a value that you got from the parameter, and then the password, and password equals whatever the password is. Well, consider what would happen if the username was single quote space or equals 1 dash dash. and the password doesn't really matter. In this case, it's foobar1. When it's all put together, it looks like this. Select star from users where username equals single quote, or 1 equals 1, and dash dash, anything after that is interpreted as comment by the SQL interpreter. So now you have a statement where username is empty string. You know it's not going to happen, but it has or 1 equals 1, which is always going to be true. So you just retrieved all the records. Depending upon how you wrote the logic, you probably allowed the user to log in. So you want to use prepared statements. Again, JPA does the prepared statements for you, but if you yourself, you want to do this. Now, of course, using prepared statements has many other benefits. For example, it's performant. It also helps you to have Irish names like O'Brien, O single quote Brian, or O'Connor, whatever you want, because if you do the concatenation yourself, those things don't work. So even functionality-wise, it doesn't work well. Protecting message queues. So, data comes in from the client. It could be through an API, it could be through the form interface, whatever it is. Your application server picks up the data and may decide to take that data and put it in some kind of a message queue. It may, massage the data, maybe pull some things out and put it into a message queue that could be consumed by other services, other integration services that you may have within your organization. And if those services pick up the message from the message queue, you get into a situation called poisoned messages in messaging. So if you put a message into a queue, and let's say the EIS tier or the MDB, the message-driven bean, tries to pick up the message, typically it does it in a transactional way. It starts a transaction, picks the message up, processes the message, but the message could not be parsed because there was an error in the message, so basically lets the transaction go, the message is put back. And then the next message-driven bean comes in, picks up the message, and so it keeps on doing this thing. If you ever notice, your application server has something called a dead letter queue that you could configure, or many of them have this. And the reason for that is because of this. Because you could put a message in, and it becomes what is called a poison message, and your message-driven bean is just simply churning through the same poison messages again and again and again. So you want to make sure that you validate it. And the validation is very, very critical over here, right? We talked about validation, and especially if you're writing HTML, JavaScript code on the client side, there's this validation confusion. Oh, I validated in HTML and JavaScript. Well, you got to validate in HTML, JavaScript, you got to validate in the web tier, and you probably should even validate in the EJB tier, because it's completely possible that you may have clients within your company that may access the EJB tier directly. And also, when you put messages in the queue, you might want to configure the queue to have certain sizes, because you don't want somebody to put in a 10 megabyte message into a queue. Protecting integrated systems. Now, many times, your application would end up talking to some kind of a system within your company, a service within your company. It may end up talking to a service outside your company, maybe in the cloud. So in that case, you're opening connection to that particular site. You want to make sure that you're using SSL to do that. Make sure that, and if you have to use client search, use client search. Use JSSE so that you can do an SSL communication. And the other interesting thing about EJBs, and it's a less known fact, when you actually have EJBs, many application servers have this concept called max beans in pool. So, for example, if you have an application server that is going to be talking to a mainframe system, and you can only have 15 connections to the mainframe system because of the limitation there, you can actually set max beans in pool for that particular stateless session bean, so that no matter how many requests that come in, the amount of, there's only going to be 15 beans that are in the pool, so only 15 connections will be established to the application server. So if there is even a denial of service attack that takes place in your application, lots of requests coming in, at least you're not transforming that particular request into your internal systems or external systems. There was a situation where somebody made a request to us, and we didn't do that, and we were making requests to Google, and Google was like, wait a minute, why are you sending so many requests to us? Well, that's because we didn't actually limit our resources on our application server through a mechanism like this. Okay, so Funny is going to talk about some of the challenges with this.
All right, let's look at some challenges or limitations that we came across in Java security. So one of them is there is no out-of-the-box support for SAML-based authentication if some of you are trying to do single sign-on. You could do it, but you have to write code yourself to support that, so it's not out of the box. That's one limitation I see. And so talking about web applications, there is no concept of remember me in Java EE. So let's say if you want persistent sessions or if you want your users to be able to use remember me functionality, then you have to resort to programmatic. Yeah, but if you wanted to support it for use, I mean, there is a balance between security and user friendliness, right? So the more secure application is, you're basically giving up a little bit on the user friendliness. So depending if your application needs it, it's not there. So it's always good to have something. Error messaging. So if the authentication fails, there's no rich error messaging. It basically, like for example, form authentication, it just takes you to the error page. So it will be nice to have some little bit more error messaging that's not there. And for URL logout, so let's say you want to support the logout functionality for first, but basic and digest, you can't do logout. You have to close the browser for the session for you to basically lose the session. So you basically can't do it. But then if you take form authentication, you have to go to the code. So there has to be a servlet which basically does a logout, which session will validate a session, or basically calls the logout method on the request API. So it'll be nice to have some kind of a URL pattern, just like JSecurity check. If you have something like JLogout, which basically automatically does that, it'll be easier. And then there's no support for, or limited support for regular expressions for URLs. So back in the security constraint in the web tier, we said the URL pattern is, for example, payroll/star. So that's okay, but then if you want to put a regular expression in there, saying something like secure, star, secure something, you really can't do that if the specification does not support that. And linking the groups, principals to roles happens, is very vendor specific. So Karthik showed an example of how you can do that in Glassfish web.xml. So again, that kind of put a limitation on the portability of it because you're trying to do vendor specific stuff. And you're not able to define, again, this probably is a very corner case. So the roles are being defined as part of your web.xml or as part of your application using declare roles. So it's actually in the code. So yes, the application is running tomorrow. If you want to add new roles, or if you want to just remove a role altogether, you cannot really do it on the fly. You basically have to change your code to do that. So it would have been nice if it was actually in the Realm itself, or if somewhere in the JDBC Realm, if you can define that, that would have been nice. So that's my thought on that. So in summary, so we all, I hope you all agree that security is a problem, and basically more and more enterprise applications moving in the cloud. So it's basically, it's only going up, the security risks are only going up. And Java EE provides several security mechanisms. So I think it's important to understand what it offers, and so we can use them efficiently. And always think security first. While building software, keep security in mind. Think secure platform, secure design, secure development, secure testing, and secure deployment. There's a few other security-related sessions in this JavaOne conference, which are not done yet. So if anyone of you are interested, you can basically take a look at those sessions. Okay. And thank you for listening. And one thing we request you is we would like to know how you feel about the session. What is it that you're looking for? Really obtain what you're looking for. So please take a couple of minutes to give feedback on the schedule builder so we know exactly how we did. Okay. Thank you. Thank you.